What if the next big scientific revolution, the one that changes how we understand the universe and our place in it, doesn't come from some massive experiment, the kind with huge, complicated machines?
Yeah, like smashing atoms in a giant collider.
Exactly. What if it comes from an AI? An AI looking at data, finding something we missed.
That's what we're diving into today, this potential discovery from Google AI. They've seemingly found a new particle.
A particle that throws a wrench into, well, the rule book of physics as we know it.
The standard model, to be precise.
Right, the standard model. The thing is, it's already a pretty strange rule book when you really think about it.
It is, isn't it? We often picture the universe as made of these tiny little balls, these particles.
Yeah, like a cosmic game of marbles or something. But it's
hmm
way more bizarre than that.
Oh, absolutely. It's really about fields. Like, imagine invisible fields that govern everything.
Like the magnetic field around a magnet. You can't see it, but it's there, making things happen.
Exactly. And there's a field for everything, or at least for every fundamental particle. There's the Higgs field, the electron field, the quark field, all overlapping all the time, everywhere.
And it's the Higgs field that gives particles their mass, like it's some kind of cosmic speed regulator.
Kind of, yeah. It determines how particles move through space. But even physicists, they often just talk about the particles themselves.
Right, because it's easier to picture a tiny ball than an invisible field. But these fields, that's the real story.
That's where the standard model comes in. It's our best attempt to map all these fields and the particles they create. And it's been incredibly successful so far.
Like with the Higgs boson, it was predicted by the standard model, and then boom, we found it.
Exactly. Major confirmation. But this new particle, this wasn't on the map. It's like finding a new continent. Completely unexpected.
And here's the kicker. It wasn't a human scientist who spotted this. It was an AI. An AI looking at quantum data, the kind of stuff that would melt our human brains.
That's the thing about quantum data. It's unbelievably complex, way beyond what we can easily process. But an AI, with its ability to see patterns, to find these subtle anomalies.
Anomalies we'd probably just miss.
Exactly. And that's exactly what happened here. This AI saw something weird, something that didn't fit.
And the scientific community's kind of freaking out, right? I mean, in a good way, mostly.
It's a mix of excitement and caution. I mean,
Right.
if this is real, if this particle actually exists.
It's not just a new discovery, it's a whole new understanding of how the universe works. We're talking rewriting the textbooks, maybe even starting a whole new physics library.
That's what we're going to explore in this deep dive. How did this AI make this discovery? Why is it such a big deal? What are scientists saying?
We'll also get into this idea of a fifth fundamental force.
Right, because our current physics only has four: gravity, electromagnetism, and the strong and weak nuclear forces. But there might be another one out there.
And maybe this new particle is the clue. We'll look at why the AI might have succeeded where we haven't. Imagine the moment when the AI was like, hey, something's not right here, and the potential impact. This could change how we think about dark matter, even extra dimensions.
And of course, we can't forget the skeptics. They're important. They keep science honest. We'll look at why they're being cautious.
But then let's imagine, what if it's real? What happens next? Is this the key to understanding dark matter?
And there's this idea of a secret history. Hints of this particle may be appearing before, but we just didn't understand them.
And what does this all mean for the future of science? Are we entering an age where AI is leading the charge, making discoveries we wouldn't even think to look for?
It's a lot to unpack. But let's start with how this all went down. We know from our sources that it happened at Google's Quantum AI lab.
Right, and they had these AIs basically swimming through oceans of data from particle collisions, the kind of data that would take us, what, lifetimes to analyze?
Probably, yeah. And this wasn't just number crunching. This AI, Google AI Studio, it was trained to look for patterns.
But more importantly, it was trained to look for things that didn't fit the patterns, the anomalies.
And then, out of all that data, this AI raises a flag. It's like, hold on, this is weird.
I bet the first reaction was, did we mess something up? Is this a glitch?
Oh, I'm sure. I mean, errors happen, especially with complex quantum simulations.
Yeah.
But here's the thing. This anomaly, it kept showing up in different data sets, different experiments. It wasn't just a one-time blip.
And the numbers, they didn't match any known particle. This wasn't just a new flavor of something we already knew. It was something totally off the charts.
It was a signal that, according to everything we thought we knew about physics, shouldn't be there.
I can just picture the phone calls, the emails flying back and forth between physicists, especially at CERN, at Fermilab.
It would have been pandemonium,
Yeah.
controlled pandemonium, of course, but still. Because if this AI was right, it meant the standard model, the bedrock of particle physics.
The thing we've been basing everything on for decades.
It was incomplete, maybe even fundamentally wrong.
And that's a big deal.
Huge. I mean, think about it. The standard model has been incredibly successful. It explains all the known fundamental particles.
The ones that make up everything we see and touch.
Exactly. And it explains the forces that govern those particles.
Yeah.
Electromagnetism, the strong force that holds atomic nuclei together, the weak force responsible for radioactive decay.
And for a long time, every new experiment seemed to just strengthen the standard model. It was like, yep, nailed it.
Right. But this new particle, it's like finding a piece that doesn't fit in a puzzle you thought you'd finished.
And it's not just any puzzle piece, it's a piece that suggests there's a whole other section of the puzzle we didn't even know existed.
And that's what's so exciting. It's like we've been staring at this incomplete picture of the universe, and now, maybe, we have a chance to see the full picture.
To answer some of the biggest questions we have.
Exactly. Like dark matter. What is it? Where does it come from?
And dark energy, the mysterious force that seems to be pushing the universe apart faster and faster.
And how does gravity, the force we all experience every day, how does it fit into the quantum world, the world of the very small?
These are questions the standard model hasn't been able to answer, but maybe, just maybe, this new particle is the key.
And the reaction from scientists has been fascinating. You've got some saying, this is it, the breakthrough we've been waiting for. But you also have others, understandably, being more cautious.
Like Dr. Anya Sharma at CERN. I read that she said the findings are remarkable, but requiring rigorous independent verification.
Exactly. And Dr. Kenji Tanaka at Caltech, he pointed out that this could be a transformative moment for AI in scientific discovery.
But he also said, and rightfully so, that we have to be sure the AI isn't misinterpreting the data.
Right. Is it seeing something new or just seeing something we already know in a new way? That's a critical question.
It really makes you wonder, could this be the evidence for a fifth fundamental force, one that's been hiding in plain sight all along?
It's certainly a possibility. The standard model, as we said, it describes 4 forces. But there have always been these hints, these theoretical ideas that there might be more.
Maybe a force connected to dark matter or to how the universe is expanding?
And if this new particle interacts in a way that the standard model can't explain,
Then that's pretty strong evidence for something new, something fundamental.
a whole new force shaping the universe.
And the fact that an AI spotted this when we, with all our big brains and fancy experiments, didn't, it's kind of humbling, isn't it?
It is. We've built these enormous machines, like the Large Hadron Collider, to smash particles together.
We've developed incredibly complex mathematics to try and understand what happens.
And yet, this AI, just by looking at data in a new way, might have found something we missed.
And it wasn't even specifically looking for this particle.
Right. It wasn't programmed to say, go find a new force. It was just doing its thing, analyzing data, looking for patterns.
And that's what's so incredible. It suggests that there might be all sorts of other things hidden in the data we've already collected.
Things we haven't even thought to look for.
So what if, and this is a big what if AI is the key to unlocking these secrets? What if it can see things in the data that we're blind to?
It would change everything. It would mean that we're entering a new era of scientific discovery where AI isn't just a tool, it's the lead explorer.
And if this particular discovery is anything to go by, it's an explorer that could lead us to some pretty amazing places. I mean, just imagine the scene at Google when the AI first flagged this anomaly.
You can picture it, can't you? The team huddled around the monitors, seeing these results that make no sense.
And then the slow dawning realization that they might be onto something huge.
That they might have stumbled onto a clue that unlocks one of the biggest mysteries in physics.
And that feeling of being on the verge of something truly groundbreaking.
Mm-hmm.
That's what drives science forward.
It's what pushes us to explore, to question, to challenge what we think we know.
And the potential implications of this discovery, if it's real, they're mind-blowing.
Absolutely. We're not just talking about adding a new particle to the list. We're talking about potentially changing our understanding of the universe at the most fundamental level.
We might find new forms of matter, new dimensions of space, new ways to harness energy.
We could revolutionize fields like quantum computing, space travel, even medicine.
But we have to be careful, right? As exciting as this is, we can't just jump to conclusions.
Of course not. That's where the skepticism comes in. And it's essential. Scientists are looking at this very carefully, asking tough questions.
Like, could the AI be misinterpreting random noise in the data? Could there be some other explanation for what it's seeing?
These are valid concerns. Extraordinary claims require extraordinary evidence, and the scientific community is taking that very seriously.
So what happens next? What are the steps to verify or, well, debunk this discovery?
Well, first, other scientists need to try and replicate the findings. That's the cornerstone of science.
So teams at other labs, like CERN, they'll try to do the same experiments, analyze the data in the same way, and see if they get the same results.
Exactly. And if they do, that's a big step towards confirming that this is real.
Uh,
But even then, there will be more tests, more analysis, more scrutiny.
and this whole process could take years. Science doesn't move quickly when it comes to something this fundamental.
No, it doesn't. But that's a good thing. We need to be absolutely sure before we rewrite the textbooks.
And speaking of textbooks, the potential connection to dark matter is really intriguing.
It is. I mean, dark matter is one of the biggest mysteries in physics. We know it's out there, making up most of the matter in the universe.
We can see its gravitational effects on galaxies, but we have no idea what it's made of.
Right. It doesn't interact with light, so we can't see it directly. And it doesn't seem to interact much with ordinary matter either.
Which is why it's been so hard to study.
But if this new particle, if it interacts with dark matter in some way,
That could be a game changer.
it would give us a way to study dark matter, to finally understand what it is.
It could unlock a whole new understanding of the universe.
And then there's this secret history aspect, the idea that maybe we've seen hints of this particle before.
Right, like in old experiments, maybe even in classified military research.
There are these tantalizing stories about unexplained signals, anomalies that didn't make sense at the time.
Maybe they were dismissed as errors, or maybe they were just filed away, waiting for someone to come along and make sense of them.
And with this new discovery, with the possibility of a new particle, a new force,
Maybe those old anomalies suddenly start to make sense.
it's like we're piecing together a puzzle, and this new piece could connect things we never thought were related.
So where does all this leave us?
I think it leaves us at a really exciting point in the history of science. And AI has potentially made a fundamental discovery.
A discovery that could change everything.
And even if it turns out that this particle isn't real, even if it's just a fluke,
The fact that an AI could even make us think this way, that's significant.
it shows the power of AI, its ability to see things we can't.
And it makes you wonder, what else is out there? What other secrets are hiding in the data, just waiting for an AI to find them?
We're entering a new era of exploration, and AI is leading the way.
So just to recap, Google AI has found something in the data, something that looks like a new particle. And if it's real, it could revolutionize our understanding of the universe.
It could mean a new fundamental force, new insights into dark matter, and maybe even new technologies we can't even imagine yet.
But the scientific community is being cautious, as they should be. They're working to verify the findings, and that will take time.
And there's this fascinating historical context, the idea that we might have seen hints of this before, but didn't recognize them.
And I think the biggest takeaway here is the role of AI. It's not just a tool anymore, it's a partner in discovery.
And that's something to think about. If AI can make these kinds of discoveries in physics, what can it do in other fields? What other mysteries can it help us unlock?
What other secrets of the universe are waiting to be found?